And we're live. Good afternoon, good morning, good evening, wherever you are. Welcome to the stream. We have another amazing workshop for you today. We have Dan Forbes from Parity Technologies, and we are going to dig into building a blockchain the easy way with Substrate and what that means. But before we dig into it, and as folks continue to join in on the stream, I like to get to know our workshop facilitator a little bit better. So, Dan, how are you doing today?
I'm doing great, Jordan. How are you?
I'm doing fantastic. I'm super excited about anything Substrate and Polkadot related. It's like on the cutting edge, and I love learning new tech. And so I'm very, very excited about your talk today. But I want to know a little bit. I've been asking everybody that joins the stream, what was their aha moment for getting involved in the blockchain space? I feel like everybody has a little bit of a different story and a different pathway in it. So what was that like for you?
Totally. I think like a lot of people, like there was just kind of like this creeping like awareness of like cryptocurrency and like it related to this blockchain thing, and then, I became a software engineer, and I would spend my time at night, kind of trolling Reddit and looking for like new exciting stuff out there. And in 2017, there was a lot of, excitement developing around Ethereum, and I kind of played around with it a little bit at that time and actually got pretty excited by it and actually looked for some people to maybe, start up a little project or start working on something. And it never really went anywhere. So, kind of life went on and that was that. And then in 2019, I had the opportunity. I was looking for a work from home software engineer job, but I got the opportunity to take a work from home developer advocate job in the blockchain space. And it was like just too good of a thing for me to pass up. And yeah, that was like a year ago, and here I am.
That's amazing. So, so like it started out like the seeds were planted years ago, but they didn't kind of sprout or come to fruition, but a little bit more recently.
Exactly.
So that's super interesting, super exciting to know. Yeah. So I know that you also you come from the hospitality industry before you dove into like computer science. So I'd like to get to know how that's colored your view of the blockchain space and what kind of implications might that have?
Yeah. So I can start by just kind of talking about how it's colored my view of like a software engineer, because I think that's where I really first noticed it. Like what the hospitality industry, it's another way of putting it is cooking school. I went to cooking school. And so it really what it is it's customer service at the end of the day. And customer service is something that's really super important to me. And that was something that I realized when I was working in the hospitality industry. I recognized that was how I approached my career as a software developer. And, this kind of dovetails with like seeing that opportunity to be a developer advocate is something that was like too good to be true, because it's this kind of role that you may hear of, but it's not a super duper common one. I think it's one that's well suited to a developer that takes customer service seriously. And then I think there's a lot of room to bring that perspective to blockchain, because I don't think that blockchain is a very customer friendly type of technology right now. And so having the opportunity to contribute to those kinds of manifestations of this technology that are both friendly and kind of move the needle of the world in a direction that I'd like to see it go is really exciting.
Yeah, there's admittedly a big UX gap, and
Yep.
that's definitely it needs a human approach to solving. You touched on something there about like the future that you kind of see blockchain being able to provide. Tell us about that. I know we're getting into more like
visionary.
Yeah. So
Yeah.
let's take a peek into your mind there.
I mean, I'm really into like people, at the end of the day, and like interacting with people, and the mechanisms that we use to interact with one another inform the nature of our interactions. And I believe that blockchain is today providing novel mechanisms for human interaction, net new ways that people can engage with one another with respect to trust in particular. And I believe that it has, a lot of potential to offer many more types of interactions, that people will build on it, like the internet was like a quantum development in terms of the way that people interact with one another. I think that blockchain is going to be a very similar type of trajectory.
That's awesome. Yeah. I think a huge part of the value proposition for me when I was coming in the blockchain space, like seeing the idea of smart contracts and the concept of a DAO, like a decentralized autonomous organization, that sounded so amazing to me, and like the future of being able to collaborate with people all around the world or in large areas that, it's the don't trust but verify, and that game theory aspect of everybody kind of acting in their own best interest, but also that acts in the best interest of the entire community. Something that's super interesting and very human, right? It's a very human thing that we want to live in communities and organize. It's just there's obviously large issues involved when dealing with large populations. So that's super awesome. Okay, I think we're going to dive into it, and we can. I love this conversation, but we can dive into it, and maybe we'll get some questions towards the end. But on that note, I'd like folks to take a look to the bottom of the screen and notice that there is a Ask a Question button. So please feel free. Dan wants you to speak up if you have a question during the talk, and if you need clarification on anything, we'll make sure that you get your questions answered. If you see a question there that you really like, you can upvote it so we can make sure that we're getting to all the super important questions for you guys. Also, just beside the Ask a Question button, there is a polls button. And I'm going to put a few polls up right now for folks to answer. Feel free to go in there and answer some polls. And we'd like to get some feedback from you guys wherever you are in the world. Super cool. I think that is about it for the housekeeping. And so on that note, I'd like to introduce Dan Forbes. Dan has worked in the hospitality industry before he got his computer science degree and became a software engineer. Today, Dan is passionate about helping other technology enthusiasts learn how to make the most of Parity Technologies, especially the blockchain runtime developers working on Substrate and FRAME, which we're about to learn about today. When Dan isn't helping to build the future of decentralized web, he enjoys spending time with his lovely two Great Danes. And before I fully pass it over to you, Dan, what are your darlings' names?
Yes, I love every chance I get to talk about my dog. So I have two Great Danes. They're both ladies, a little bit on the older side. So we have Khaleesi, who is going to be 10 years old at the end of January, which for a Great Dane is pretty old. And so we got her right at the end of the first season of Game of Thrones, as you can tell by her name. And then her adopted sister, her name is Cyan, which is like a shade of the color blue, because she's a gray Great Dane, and then people call gray dogs blue. So
that's awesome. That's amazing. I love that name. And to think that's how old Game of Thrones is.
But you know what? I like Game of Thrones is like trigger alert for me. Like I was traumatized by that last season. Still haven't gotten over it. I wouldn't recommend anyone watch the show. Like, don't waste your time.
Oh man. Did you read the books?
I read some of the books. I found them to get a little laborious.
Yeah. Okay. Before we get any further sidetracked, we're gonna jump into it. But this has been great.
Sweet.
Yeah.
Should I go ahead and share my screen and everything?
You can go for it. Yeah, I'm going to make myself small, and I will be here in the background.
All right. Okay. Oops. Well, you'll get a little preview as I go backwards through my slides. That's cool. Little teaser there. All right. Jordan, can you see everything and still hear me okay? Just so little quick check-in.
You are good to go.
Okay, cool. Yeah, so thank you for the great introduction, Joran. I do want to just talk a little bit more about what it means to be a developer advocate, because I think, it's something that people talk about, but not everyone knows what it means. Sometimes I don't think I know what it means either. When I tell people what I consider my job to be, I basically feel like I work to make it easy for people to understand the types of capabilities that Parity produces, and then I work to reduce the friction that they experience when they interact with those capabilities. And so really what I hope to do in this presentation is provide developers who want to start building a blockchain with Substrate with kind of the conceptual and practical pieces of knowledge that they need to really be effective. So that's the goal, is to kind of be this, like, I don't want to call it a crash course. We're going to call it a takeoff course. So without any further ado, let's go ahead and get started. So what is Parity Technologies? Parity Technologies, for many people, it is our founder, Gavin Wood. And Gavin Wood is like super awesome, very impressive. He wrote the Ethereum technical specification. He spends most of his day writing code. He's not like a CEO. He writes a lot of code. And if you come and join our technical chats, there's a very high likelihood that you'll get a chance to chat with Gav. He doesn't just talk the talk, he really walks the walk. So that's where kind of we come from, is kind of this Ethereum lineage by way of Gav. So we provide blockchain infrastructure, which is to say the first thing that we created was the Ethereum client that bore our name. Now we're working on Substrate, which is a framework for building blockchains, which of course we're going to talk a lot more about, but we're definitely down at the layer 1 level. We're not really building dApps or writing smart contracts. We're kind of at the core infrastructure level. Write Rust code. Rust is the most beloved programming language amongst the people that use it, but it's not really heavily in use. And so that's both like an opportunity, but also a challenge for us. But Rust is very beloved for a lot of reasons. It's fast, safe, and concurrent, I believe, which is very difficult to come by. And people really enjoy working with it. And Parity maintains one of the largest Rust code bases in the world, and arguably we are pushing Rust to some of its farthest limits with respect to like all Rust in the world. The blockchain infrastructure that we implement in Rust code is basically implementing Web3 Foundation research. So you may hear about Web3 Foundation in reference to Parity, kind of, or with respect to Parity. Web3 Foundation is the not-for-profit research side of things. So they create academic papers, white papers, develop consensus algorithms, heavier kind of math type stuff. And then on the Parity side of things, we implement those algorithms, those protocols, so more on like the coding side of things. At least that's my perspective on things. And we are the creators of the Polkadot network. Let's actually take 1 second to talk about Polkadot network. Actually, we're going to do that on the next slide. But before I dive into Polkadot, Jordan, I remember this is something that you brought up when we were kind of chatting. Let's take one step back and talk about the Kusamo network. So Polkadot network, which we're going to dive into in terms of its technical details here in a second, is kind of like our big production blockchain. I don't even want to use the term mainnet here. Think of it more as like production. There's another network that you may have heard of called Kusamo. Jordan, do I hear you unmuting yourself? Do you have a question maybe?
No, I was just gonna like join in on the conversation because I love this. I'm rocking my Kusamo shirt today, and I don't know if you can see, but close enough. It says "Expect Chaos" all over the shirt, and that's expect chaos. That's about right for Kusamo, and it's very different from a testnet, right? I hear a lot of folks thinking like, oh, that's like where they test everything out, which is true, but not exactly true. Do you want to tell us a little bit more what the difference is? So
I would say that a test net is something that, first of all, I expect to be fully centralized. I would expect some entity to maintain this testnet, and they do whatever they need to do to make sure that that testnet operates at some minimum expected level of efficiency. You know, you have things like faucets and stuff like that that really require a centralized entity to manage, and kind of that carries this expectation of like not always being super stable, I feel like, which is like at any minute it could potentially be like reset or something if there's a bug in the testnet or something like that. Kusamo is what we call a canary network. So first of all, it's fully decentralized. It's community owned. There is a community around it because we're not really using it to test the capabilities of our code. My understanding of Kusama is that it exists to test out these novel mechanisms for human interaction. We can test the code on a testnet, but in order to get them out there and get them in the hands of people and see what it's like when people actually start interacting with them before they go to production, we have Kusama, which is decentralized, not totally there's lots of expectations around like the stability of Kusama, but the community is expected to be a little bit more daring, a little bit more experimental, whereas in Polkadot, the community is expected to be a little more conservative.
That's amazing. Yeah, I love the concept of having a live, really incentivized it. It uses real world value to test out, which makes complete sense because, to use like a crude analogy, I think it's a Mike Tyson quote. It's like, he says, everybody's got a plan until you get punched in the face. Like, I think once you go live and you put your network in front of people, it's going to get punched in the face, and that plan may or may not, work. So getting it out there, failing fast, getting it out there into the hands of people that are actually going to use it with real economic incentives, I think makes complete sense, and which is why I love Kusama and the Polkadot project as a ecosystem and how it progresses things. It's awesome.
Exactly. So to kind of like try to tie this all back together, I know it's easy for us to get like real excited about this stuff. Both Polkadot and Kusama are substrate-based chains that are kind of developed, I would say, by Parity, but then maintained by the community. And they actually share a code base, which is kind of interesting, a little bit of a detail. So let's not get too far into that. Let's go ahead and take just a second to like kind of look at what Polkadot is. And this is not a Polkadot presentation. It's not my goal here to teach you everything about this diagram. That, first of all, I don't understand it. Second of all, it would take a really long time. What I want you to take away from this is that Polkadot is a blockchain of blockchain networks. So blockchain of blockchain network. So there is the relay chain, which is
sorry,
go ahead.
You need to recast your screen.
Oh yeah, that happens sometimes. Thank you for...
No worries.
Better?
Yeah, it's
okay.
About to load up. There it goes. Yeah, you're good.
Okay, cool. So here's this image, which is like, very impressive, but a little bit daunting. And so we are looking at this relay chain right here. And so this would be the Polkadot blockchain itself, but then we have all these other blockchains that are part of these ecosystems. We have the parachains, which are kind of these blockchains that are like somewhat tightly coupled to the relay chain, and there's a real expectation of kind of availability there that exists between the parachain and the relay chain. And then you have parathreads, which derive similar types of shared security and shared infrastructure from the relay chain, but there's a less of an expectation of availability. So we're not going to get into how all of this works, The takeaway is this is a system that involves a lot of blockchains, not just the Polkadot blockchain that we at Parity need to develop to enable this system, but there's also all the other blockchains that we want the community to develop, and that will be the parachains and the parathreads and whatnot. So this kind of gets us to Substrate, because as we were building Polkadot, we realized not only can this be generalized into a framework for building blockchains, it should be generalized into a framework for building blockchains in order to help us actualize this vision that requires many, many blockchains. So let's talk about how Substrate helps people write a blockchain. First and foremost, it is a framework for helping people to write blockchains. And in particular, the goal is to be flexible. And if you go back to what I just said, that kind of makes sense, because we're not just building this relay chain, we're building other types of blockchains too. And we hope, and I believe that people are building blockchains with Substrate that will be standalone blockchains, like the Ethereum mainnet, that won't exist in this blockchain of blockchain ecosystems. So Substrate is very, very flexible. You can build lots of different types of blockchains with it. And in particular, this is made possible through modular, customizable components. This is kind of like the bread and butter of software development, and Substrate does it so well. And this is something that we are able to do because of the unique capabilities of the Rust programming language. And another capability of the Rust programming language that we capitalize on is its ability to compile to WASM build artifacts. WASM is a portable bytecode execution format. It's used for implementing high performance, or it was created for implementing high performance, kind of like gaming things on the web. But really, it's just a bytecode format that can be used to easily, what's the word I'm looking for? Cross-platform high performance application development. And so Rust compiles to WASM. It can also compile to native, which would be like, oh, I'm going to compile it to run on my laptop. And then I would have to compile it for my Linux laptop. I'd have to compile it for my Mac laptop. I'd have to compile it for my Windows laptop. Or you can compile Rust to WASM, which is this portable execution format that can run in a web browser or somewhere else. And we use this in a very specific use case. We compile our blockchain runtimes to WASM, and we'll talk a little bit more about what the runtime is. But one of the really key, the secret sauce of Substrate, if you will, is this idea of a WASM runtime where the bytecode of the runtime is actually an element of the runtime storage. It's kind of this like inception level thing that provides some really cool capabilities that I'll talk about. But for now, let's just move forward with this understanding that Substrate is a flexible, customizable framework for building blockchains. And something that's really important is this idea of WASM runtimes. So now we have a kind of a framework within a framework, which is Frame, and it is a framework for building runtimes. So every Substrate chain must have a WASM runtime, but not every Substrate chain must implement that runtime in Frame. That's just kind of the approach that we take at Parity. It's the one that we personally invest most of our efforts in. And so therefore, like personally speaking, it's the one that I would suggest for people to use because it's the one that I can help them with. So we're going to talk a lot about what Frame is and how it makes it easy, how it simplifies runtime development. We're going to dig into this idea that there are Frame modules that we call palettes, and you can mix and match existing palettes, or you can build your own palette. But before we dig into that, let's kind of pull back out a little bit and look at Substrate as a whole. Jordan, this is a good time for me to just check and see if there may be any questions.
So far, so good.
Cool.
No questions at the question box, but walking time is over. It's now runtime.
Indeed. And please do, ask questions if I'm, kind of getting too much in my own knowledge and forgetting to make things accessible. Please feel free to just hey, please jump back and explain that or something. I'd love to do so. But, I'll go ahead and keep moving with the presentation for now. So when you build a Substrate project, what you end up with is this, essentially. It is a blockchain node. It is an application that you can run on your computer, a native application that you run on your computer that allows you to participate in this blockchain network. And what is a blockchain network? A blockchain network is a distributed system that allows a network of participants to trustlessly come to consensus on the state of a system as it evolves over time. And so let's key in on that state of a system. Another term that you may be familiar with is this idea of a state machine. And that's essentially what the runtime is. In Substrate, we say that the runtime is the state transition function. It is the block execution logic. So the runtime can be thought of as a set of instructions, a set of acceptable transitions that can happen. And you then have some mechanisms that allow people to interact with those transitions, to affect those transitions. There's then mechanisms that allow this distributed network to trustfully come to consensus on which of those state transitions in the long term is the right set of state transitions. And so let's talk about how this thing helps you to do that. So here is our runtime. And as you see, it is an element of runtime storage, like I talked about. We're going to kind of elide over that for now. But we have this thing, this kind of engine here inside the blockchain, this runtime. And now we want to give people a way to submit transactions to the runtime so that they can make changes to the state, but also read what the current state of things is. And so in particular, that happens through the RPC server. So one thing of a Substrate blockchain, of a Substrate node, before I move any further, is it's kind of this orchestration engine that's orchestrating all these different components. I used to work a lot with Kubernetes, which is an orchestration engine. And so that's kind of how I conceptualize things. It's like the node is kind of like this manager that's kind of dispatching tasks to all these different components. So one very important component is this RPC server. And this is what allows blockchain users to interact with the node. So requests come in through the RPC server, and maybe this is a request to read some history of what's been, what happened in the past. Maybe we want to read the storage. Sorry, let me close the loop on that. If we want to read the history of what happened in the past, we look block database, and you can see that this is actually implemented on top of the same key value database that we use to implement runtime storage. So runtime storage is this you can think of the runtime as the state machine and the runtime as a snapshot of the current state. The blocks are kind of the state history, and all of this history, current state, everything is implemented on top of the same key value database. And so through the RPC server, you can query historical state, you can query current state, or you can interact with this other component, this transaction pool, which is separate from all of these other things, modular, customizable. And this is what allows you to submit transactions, which is how you affect state changes. Once you submit that transaction, it of course needs to make its way into the runtime to see if what you're asking to do obeys all of these laws that the runtime defines. And then you also want to gossip that transaction across the network so that the other nodes in the network can do the same thing, can see if they can validate that transaction. Then, of course, there's a networking component, which I hope you can see is separate from both the RPC server and obviously the transaction pool. And so whereas RPC server is how users interact with the blockchain, the networking layer up here, lib P2P networking, this is how the blockchain nodes interact with each other. And then through the networking layer, there's another component here, which is this consensus mechanism. It's decoupled from the networking layer, which is what makes all of this so easy to customize. So the transactions get gossiped across the network. They come into the consensus engine, blocks are imported into the consensus engine, and eventually there's a determination of what the canonical state is, and that's persisted into the final key value database is the canonical state of the system. And obviously this is like all kind of super complex. And so there is an embedded Prometheus server that can be used to monitor all of this. Let's go ahead, Jordan.
I got a quick question here. Yeah. So the consensus mechanism is separate from the runtime, but as I understand it, it is still modular. So you can swap in a different consensus algorithm as well. Is that right?
Absolutely. Yeah. And so you can have the consensus mechanism that interacts with the runtime, or maybe you have a relatively simple consensus mechanism that doesn't need to interact with the runtime. This is a simplified diagram, so it's not showing every possible interaction. It's kind of showing like a very simplified flow, but it is possible for the consensus mechanism to call into the runtime, which is certainly what we do in Polkadot. But you can have other types of consensus mechanisms. You can have consensus mechanisms that support finality and consensus mechanisms that don't support finality. So all of this is possible with Substrate.
Super cool. And another question then I also have is that lib P2P part there. That's a common thing in general blockchains. Like Ethereum uses this, and so Parity has a strong hand in maintaining and building this out. Is that right?
Yes, correct. So libp2p is a networking stack. So it's a multi-protocol networking stack that has implementations in many different languages. But Parity we have some of the largest contributors to the Rust implementation of the libp2p networking stack. And it is kind of the engine that powers the flexibility of our consensus mechanisms. Because libp2p has so many different types of protocols that it supports, you can implement different types of consensus mechanisms in a performant way.
Super cool. Fascinating.
One kind of point here that I haven't talked about is this executor component here. We talked a lot about the fact that Substrate uses WASM runtimes. That is a necessity, but an optimization is that because both the outer node and frame are written in Rust, we co-compile the runtime to native, and so this becomes very useful when you're syncing a node. So the reason why it's good to have the runtime as part of storage is that it makes it very easy to update the runtime. The participants of the network, just like they can trustlessly come to consensus on how many transactions have happened or how much money I transferred to Joran or that kind of stuff, they can actually leverage the core capabilities of the blockchain itself to actually come to consensus on the rules that the blockchain defines. It's this very elegant concept that's a little bit difficult to explain, if I'm quite honest with you, and sometimes even wrap your head around. But we have a really great tutorial, the Upgrade a Chain tutorial, and I'll make sure to drop a link to that later. But it walks you through how you can use Substrate to update the definition of the runtime and kind of bring all this to life. But I want to bring this back to the executor. If you know that you are working with the latest version of the runtime, as in the somewhat common case of when you're trying to sync a new node. So you want to sync a new node, you've pulled down the binary, and you have like all these blocks that you need to chug through, and you want to do that really quickly. If your native client contains the most up-to-date runtime per the network, the executor will select to use that native runtime, and you can see a really large performance increase in the speed at which the node syncs. So this is a bit of like an optimization, and I'm kind of like breaking an abstraction here, but it's something that kind of defines Substrate, and so I think it is something that's important to bring up. So let's move on. Go ahead, Jordan.
I think it's like we can't overstate here like the magic that happens due to this kind of mechanism, where when it comes to upgrading, where in other chains you would create potentially a hard fork, like you can upgrade the chain without having to fork it and without nodes needing to perform a direct action. So that's super powerful.
Exactly. You don't need any kind of like foundation, like coordinating the upgrade or anything. The coordination and consensus mechanisms of the blockchain do that for you. So it's quite elegant. Let's talk a little bit about what the runtime is, because I know it took me a couple of months to really kind of like fully feel like I understood this. So the runtime is a state machine. It defines possible state transitions and the APIs, the methods that allow you to affect those state transitions. And so this is a really good time for me to like thank my wonderful colleagues who helped me develop these cool images. I'm not a visual person, I'm a word person, if you can't tell. And so I hope what these images evoke for you is this idea of configuring a state machine. And really keep that in mind when you're thinking about what the runtime is. It defines the transitions that the state machine can take. And then before I talk about this idea about state transitions persisting to storage, when you think about a state machine, certainly when I think about a state machine, it kind of brings to mind like these kind of old clunky, mainframe computers that had like punch cards, And so you think about the punch card basically being this definition of a state change, like go toggle all these switches and now your state is that thing. And so essentially what the runtime is it's a way to affect these changes, and a transaction is a punch card. And so the transaction says, I want you to change the state in this way. It may or may not be valid. The runtime will evaluate that. And then when you think about a block is like a big stack of those punch cards. So you can say that in this block, these state transitions happened, and as an aggregate, they are valid. Each one individually is valid, and as an aggregate, they are valid. So that is kind of the core capability of a blockchain, and that's what the runtime does. And once we come to consensus on this, per the blockchain, we persist this to storage in the block storage that I showed you earlier. We talked about the fact that the definition of the runtime is an element in storage. So you can include a transaction in a block that actually changes the definition of the runtime. So in the block that you submit that transaction, there's one set of rules for evaluating things. And then all of a sudden, as long as that runtime respects the rules that exist at that time, there's now a new set of rules in the next block. It's really cool and really fun. That's the idea of forkless runtime upgrades. And that is enabled by this special sauce of WASM runtime WASM runtimes that are an element of storage. And then remember, none of what I just said was in any way specific to Frame. Frame is just kind of our preferred library for building Substrate runtimes. It's written in Rust. And now let's talk a little bit more about Frame. So from my point of view, the most important thing to remember with Frame is this kind of compositional thing. So you basically define a runtime as a set of modules where each module has a fairly specific concern. So the pseudo concern, the pseudo module, or as I mentioned before, in Frame, we call our modules palettes, just a little bit of jargon there. The pseudo palette, it provides your runtime with pseudo-like capabilities. In addition to this idea of composability and composing a runtime by a set of modules, Frame also establishes certain primitives for you. And one of these primitives is the idea of an origin, which is where a transaction comes from. And so, of course, one very common type of origin is an account. Like I sign a transaction and I submit that to the blockchain and it's attributed to my account. But keeping with the flexible nature of Substrate, there's actually other types of origins that I'm not going to get into right now, because what I want to talk about is, I guess I will talk about one other origin. There is this like special origin, this idea, it's a primitive that Frame establishes of the root origin. And this is the origin that has admin capabilities in the Frame system for runtime development. So we talk about forkless runtime upgrades. If you choose to use Frame, the only origin that can perform these upgrades is the root origin. And so what the pseudo palette does is it exposes a mechanism by which you can associate a single user account. So a user account can sign a transaction, and it will basically help make the transition from that signed origin to this root origin. So you kind of use the pseudo palette to proxy a root call. And if you're familiar with like Unix or Linux development, you probably understand why we use the word pseudo. It's the super doer user. So that is one type of capability that you could or could not include in your runtime with Frame. This is obviously a very primitive type of governance. It's like the dictatorship form of governance. You have an entity who can manage things. There are other palettes that expose more exciting types of governance. There's a democracy palette. There's other palettes that do other things, like a palette that implements the Ethereum virtual machine. So this is all to say that Frame sets up some primitives for you, and you create a Frame runtime by composing modules, which we call palettes. And so what is in one of these palettes? It has, let's just talk about it. It has this trait configuration interface. So this image here is meant to kind of indicate that the runtime is composed of other palettes, all of which are providing some capabilities. And then we want to somehow inject some of those ideas into a palette that we may be including in our runtime. So for instance, let's say that we are writing a smart contract palette that's going to allow our users to deploy smart contracts to our blockchain. They're going to need some way to pay for gas. So we are going to need to use this trait configuration interface to tell the palette, okay, this is the currency that we're using from the outer runtime. You know, maybe it's the native currency of the chain, or because Substrate is flexible, it could be another currency. Substrate chains can have multiple currencies. And so you would use this trait configuration interface to configure the right currency to use. And you can do other things with it, which we'll talk about. Of course, storage is very important. to the runtime. We talked about the fact that the runtime is basically just rules around how storage can be changed. And so when you write a palette, you have access to storage primitives. Then as people are interacting with this storage, they're either going to make successful state transitions, and we emit events to let them know that they were successful and maybe some of the details of the state transition, or sometimes things aren't successful and we have to emit an error and let them know that an error occurred. And so in a frame palette, you define both errors and events. Dispatchable transactions are something that you define within a frame palette, and these are the things that you call into from the RPC, like we looked at. So this is really how like blockchain users would interact with your palette, but then palettes can also interact with one another. And so in addition to defining transactions within a palette, you can define public interfaces which other palettes may call into. Okay, let's take a second to look at some template projects. And I'm just going to go ahead because I'm already a little kind of beyond the time that I was targeting, not freaking out too much about that. But basically, I've kind of now gone over most of the conceptual stuff. I guess this is a good time for me to pause just to see if there's any questions on any of the conceptual stuff, Joran.
Yeah, so it still looks like we're chugging along. No direct questions from the audience. I'm thoroughly enjoying this. FRAME, quick question. FRAME is an acronym. Do you know off the top of your head what the acronym is?
I do know off the top of my head what the acronym is. It is the Framework for Runtime Aggregation of Modularized Entities. It's a mouthful. It's a mouthful. It took me a couple of weeks just to get that acronym. I won't lie to you, but it is actually. It actually makes sense. It's not like just some crazy backronym. And I'll talk a little bit about, but let's break it down one more time, and then I'll show you why I think it's not just a backronym. It is the Framework for the Runtime Aggregation of Multiple Entities. It's a bit of an acronym because I wouldn't say that we're aggregating the modules at runtime, but we are aggregating modular entities to create a runtime.
That's I think it definitely makes sense.
Yep.
And I think the an acronym is already extra helpful when it like spells out a word that makes it conceptual. It is a framework in itself that allows things to work together, and like I get a visual when I like say it and I like imagine it.
Exactly.
Yeah, that's amazing.
And I think like this idea of framework really comes into play when we talk about those primitives that I was talking about. It kind of gives you like the scaffolding to hang your ideas off of.
100%. We did get a question here from the audience.
Sweet.
And they're asking, is there a DAO or opportunities to get paid for developing on this from a decentralized fashion?
You betcha. There's multiple substrate-based DAOs. So both the Kusamo network and the Polkadot network have what I would call at least two DAOs. So they both have a council and a technical committee. And on Kusamo, in the spirit of being a little bit more pushing things, they have enacted a mechanism for decentralized bounties. And the first bounty is live, and the bounty is for a better UI for the bounty mechanism. So it's like really cool, kind of this like Inception thing again. And the answer is yes. And I will provide some links to that. I'll provide some links. That's a great question. I love that you're asking about DAOs, because kind of tying some thoughts back to what we were talking about at the beginning, Joran, I think that Substrate is really a very human blockchain. The idea of needing to upgrade a blockchain if you are a human, particularly a human who writes code, is kind of intuitive to you, because when is the last time you wrote a piece of code that you never needed to change? It's like scary to think about writing code and not being able to change it. And so just that core concept of an upgradable blockchain is very human, very powerful. But then it creates all these questions around how do you manage those upgrades. And so there, as I showed on this slide, there's many kind of governance mechanisms that we have implemented in Frame to make it easy to build flexible entities, on-chain organizations, entities, collectives, however you want to describe it. So that's a great question for the Substrate ecosystem. All right. Anything else before I kind of start showing off a little code?
Yeah, I think we're good to move on.
Cool. Yeah. So I just wanted to kind of like get off the slides, obviously, and kind of show you guys what this all looks like in real life. Jordan, you can still see my screen, right? The GitHub up here.
Yep, looking good.
Okay, great. So Jordan will share these slides with you guys, so you guys should have access to all these different links. And so right now, I'm just looking at this first link on this slide. It's the node template. This is really where I live and breathe. If we go back to this, the node template is really kind of like one of these with training wheels. And to be quite honest with you, I still kind of have my training wheels on. Like, it's a lot to learn this stuff. And so starting with the node template is a great kind of simple place to wrap your mind around all of this and then get started building a project of your own. So let's take a look at that. The first thing I want to look at is this template palette that ships with the node. This is, of course, a frame-based blockchain. So it ships with this template palette that is really mostly, or certainly a lot of comments, because it's really just meant to be educational. Basically, it kind of shows you placeholders for all of these things that I talked about. So here is the configuration trait. And you can see right here, we are configuring an event type. So we talked a little bit about you emit an event from your runtime when a transaction was successful. And if you're familiar with Ethereum development, this is probably something that you're pretty familiar with. And so to kind of take it back to what I was saying about hooking up, remember, let's go back to this slide. I want to try to kind of hooking up the outer runtime's idea of something with the palette's idea of something. The outer runtime is going to have some idea of what an event is, and my palette wants to be able to emit events, but they have to be compatible with the runtime's idea of events. So the configuration trait is where you provide those little hooks to make sure that everyone's kind of talking the same language.
Sorry to interrupt. Can you give us a little zoom on that?
Yes, thank you. Good host. I appreciate it. I always forget that. Okay, so thank you, Jordan. So I was looking at the trait. Don't get me started on that name right now. Trait is Rust lingo for interface. So if you're familiar with Java, C++, or something like that, just think of Rust traits are kind of like supercharged interfaces. And we call our configuration trait, our configuration interface, the trait. Probably going to change that. I apologize. But yeah, this is the configuration trait right here. And we talked about configuring events. So we also talked about storage capabilities. The trait is a Rust interface, a Rust trait, as I said. These things that you see here that have like an exclamation point or a bang if you're a software engineer, and then enclosed in brackets, these are what's called Rust macros. And this is a lot of the magic of Frame. They're code that writes other code. So it's almost like a programming language within a programming language. And so in order to make it really easy for palette developers to interact with the low-level storage capabilities of a substrate-based blockchain, Frame exposes the Decal storage macro. And so there's some, I wrote it, so I'm very biased, but what I would describe as some good documentation around how to write different kinds of storage structures inside this Decal storage macro. So take a look at the palette template, follow this link, and learn all about how to implement different types of storage. And I'll also show you different ways to kind of learn how to do things. Basically, events are, not going to get too much deeper into this now. It's, as you can see, it's a macro. You define the events that your blockchain is going to want to emit. So a very common type of event that you might define here would be like a transfer event. Errors would be when something goes wrong. So, maybe someone doesn't have enough funds to make the transfer. That would be a type of error. And Frame just gives you a really nice, easy place to put this in a really kind of idiomatic framework for defining all of this stuff. Finally, Decal module, a macro, is where you're going to define the functions that then line up with the transactions that your blockchain exposes. So in this case, obviously the palette template isn't implementing the most groundbreaking logic in the world. We're just doing something. And so what are we doing? It's always going to basically be something around updating some storage. And so you can see that that's what we're doing. We have declared this storage structure in our Decal storage, this something storage structure. And now this is a function right here that we've defined. It's like a little hole that we've poked in our runtime that lets people make changes to this storage state. So those are the different components of a frame palette that we talked about. So now let's imagine that you've written a template, a palette that encapsulates some really interesting logic, and you want to add it to your runtime, or maybe you don't even need to write your own palette. It's entirely possible that you can use the pre-built palettes to create a runtime that has some really interesting capabilities. And so let's take a look at how you would add a custom palette or a pre-built palette, any type of palette, to your runtime. Let's pick a fairly straightforward one. We'll pick the balances palette. So this would be the native currency of this chain. This palette, this module, the capability that it represents is the native currency. So with palette balances, we define a currency, and then there's this idea of like accounts that can transfer currency back and forth between one another. That's the capability that balances provides. Maybe you can use this currency to pay for other things. So this is one of the core pre-built frame palettes that we want to add to this runtime. So in addition to configuring things like events, which we already talked about, you may want to configure bounds on the palette. So for instance, in Substrate, we have this idea of an existential deposit, which is the minimum balance that an account can have in order to be live. Obviously, there's some overhead associated with maintaining a list of accounts. And so we don't want our chain to become bloated with many, many accounts that have barely any balance associated with them. This is a scaling mechanism. And you can imagine that you would want it to be configurable, because different chains may have different scaling requirements. And so what you can do in addition, you can see that this is we're implementing the trait configuration trait here. That's what you do when you add a palette to a runtime, is you implement the configuration trait. So in addition to providing types that offer capabilities like events, you can also provide values that are like bounds on the amount of resources that the palette may consume or something like that. Another thing that we're configuring here with the balances palette, you can see we're telling the balances palette it needs to know the type to use. And so this isn't the most helpful syntax here, but let's go see where this balance is coming from. We define it up here, and we say that a balance is just a unsigned 128-bit integer, and that makes sense. Like I have $1, I have $2, I have $3. It's just some value that we represent as an integer, and this type of currency, it doesn't allow a negative balance. You can't express a debt with this type of currency. But 128 bits, that's pretty big. So even right there, we have made a lot of decisions and had a lot of flexibility in implementing the capabilities of this balances palette by selecting a 128-bit unsigned integer value as the type for balances. If I was working on a chain that I knew I wanted people to run on their phone, and so 128 bits is like just way too big, maybe I'm working in a really constrained environment and I want my balances type to be only 8 bits, and that's important for my scalability story. Substrate gives you the flexibility to change things at that level. So I hope that makes the configuration interface more clear and not less clear. I know that this can seem like a lot, but I want to show you what the code looks like of implementing this. And we do have tutorials that help you understand. I'll drop a link to that. So you're going to have a bunch of palettes that you implement, like we implemented the balances palette. You're going to decide the different capabilities you want in your node. You're going to implement all these palettes. Maybe you've written some of them on your own. And then finally, we have this macro here called construct runtime. And this basically just does exactly what it says. It uses all of these different modules to construct your runtime. And so if you're looking at a frame runtime and you want to understand like what does this runtime do, the first thing that I would do is you would come and look at the palettes that it includes in this construct runtime macro, and you would say, okay, this runtime, it has some random lists capabilities, it has some timestamp capabilities, we got balances in there, pseudo, and then maybe you might see like, oh, this is a custom palette. Let's go poke around and see what that does. So this is how you implement the runtime, how you kind of compose all of these frame palettes. Now, let's see. What else did I want to show you? I think I'm done with the node template for now, unless we have any questions about the node template, Joran.
There are a couple questions that
Great.
I think but it's not specific about the node template. I think we'll get to them towards the end, but a couple of really good questions here. So another reminder, just to drop your questions in the ask a question box and upvote the questions that you like. I see an upvoted question there that we're definitely going to take at the end. I have a quick tangential. I don't want to go too down the rabbit hole on it, but on the note of existential balances, I was curious. Like I know that like you remove the account from storage across the network when it's below a particular amount, but if you were then to send another amount of currency to that same address, it would then be brought back as like an existing account. So where does that non-existent existential balance get persisted while it's not being a part of the entire kind of network?
Yes. So I don't know a ton about that flow. There are ways to recover an account that was lost due to this happening. You bring up a really, really good question, because it showcases the composable nature of a frame runtime, because the balances palette, it doesn't manage accounts. That's not what it does. That's not the module that it does. You can even see here that an account store is a dependency of the balances palette. All the balances palette does is, how much does this account have, and the transferring logic. It doesn't do the account tracking logic. And so at one point I kind of had this question. I was like, wait a second, how can the balances palette decide whether or not an account lives or dies? Because that's happening at the frame system level. And so you can see that that's actually exactly what we're doing here. We are configuring the balances palette to use the system as its account store. And remember, I talked about some of the primitives that Frame sets up for you, some of like these fundamental idioms that it provides for runtime development. One of them is this idea of associating other types of data with an account. And so the system palette, the frame system core capabilities are materialized as a type of palette. And so that palette provides certain hooks where other palettes can say, hey, I want you to associate this little bit of information with this account. And so what the balances palette does is it doesn't kill the account, but what it may say is, okay, I'm done caring about this account. It's dropped below the existential deposit. Don't track that account on my behalf anymore. And so at some time, the frame system for account management may choose to drop that account from storage if all the other palettes that are referring to it, they don't care about it anymore. And so let me make sure I get this right. And I don't know, let me just say, I'm not sure that I'm going to get this right. Let me tell you what I think would happen. If a balance drops below the existential deposit and that account is still alive because some other palette is maintaining a reference to it, once it goes back above the existential deposit, I would assume that everything just kind of like starts working again as normal out of the box, because the account was never dropped from the system to begin with. In the event that the account is dropped completely, you could still go back to the block right before the account was dropped and get all the information that was associated with it and kind of like patch that back into storage. And so in that way, you can bring a dead account back to life, I believe.
I get it. I think that's magical. It's almost like syncing your blocks, but just for that one account. Like you're going,
yes.
Yeah.
Yep,
okay.
Exactly. And so it's super cool. It's super flexible, but it's like this thing where flexibility leads to complexity. So it can take a little bit to wrap your head around. I always get worried because I'm like, oh, I hope I'm not like scaring people off by making things sound so complicated. Let's unless you have any other questions, let me try to help make things seem simple again.
Yeah. I probably should have saved that for an offline question, but it was just like
that was awesome.
Mind, I was like, what is that? Okay, cool.
Yeah. Okay, great question. So we had what a palette looks like. Then we talked about actually composing all of these palettes by way of the runtime. Let me just come back up here and show you where I am. Again, this link is the node template link is right here, and we're in runtime src lib before we were in the template palette. So that's a little bit about palettes and stuff. And now I want let's go through some of these other resources here. I'm going to skip ahead. Let's see. The Substrate Developer Hub is really where I live and breathe. This is where you'll find a lot of great resources. And so if I go back here, you'll see that one resource that I'm talking about is our recipes. They're working examples that demonstrate common coding patterns. And so if you come to substrate.dev, you can find our recipes right up here. I'll open them in a new tab. Lots of cool materials for you to go through there, learning about all these hopefully not too complicated sounding things that I talked about. In addition to the node template, we have a front end template that you can use to make easy front ends. I think we actually maintain a deployed instance of it. Yep. So you can pull this down and you can see it's, all these kind of little components that you can easily customize or kind of pull them out if you want to. Really easy starting point to build a front end on top of the node template, which we looked at earlier. And then the last thing that I wanted to show you is if you're, trying to figure out how to do these things, maybe you want to implement a palette of your own. And so you kind of have an idea, but like you're not too sure what the best way to do it is. Or maybe you're just like, whoa, I want to learn more about this crazy balances stuff that this guy was talking about. You can follow this link, and everything that we do at Parity is open source. And one of the best references as a frame runtime developer is to go and look at the core frame palettes and see how things are implemented there. They're very, very well documented, amazingly well documented. That's all the core developers. They do a really good job at that. Makes my job really, really easy. And, then you can kind of come in here and see how we're defining the trait for something a little bit more complex. You can see we're still using events, but there's a lot more stuff going on there. The main thing that I wanted to show would be, where's my decal storage? Decal storage. It's always about the storage. So looking at the core frame palettes is a great way to kind of understand how you can implement some of these different storage types. So that is a really, really good resource as you're developing things. And then earlier we were looking at the node template that's in kind of like its own repository as like a starting point. The core substrate repo, so this is the same repository that we were in here looking at frame, the balances palette, I should say. It ships actually with a version of that node template. The node template comes from the core substrate repo, but it also ships with this much more kind of fully featured node that includes almost all of the palettes. So let's say that you wanted to include the contracts palette. You want to include smart contract capabilities on your blockchain. You could come and look and see that's one of the more complicated palettes. And so you could see how that palette in particular is implemented. And this is a really good resource when you're looking to add a pre-built palette to your runtime. So I hope that those are helpful template projects. I know that there were some links that I was going to share. So let me go ahead. I remember I wanted to share the tutorial for upgrading a chain. So I'm going to share that. Joran, do you remember if there was any other tutorials that I said that I would share? Or links, I should say.
If you have like the node template tutorial, that one's a really good one.
Yep. I think that was the main one that I said. Okay. You mean just like basically the very first tutorial?
Yeah, launch your chain. That's awesome.
This is, I kind of think of this as like Hello World for Substrate. It just kind of walks you through that process of just making sure that you can, print something to the command line, basically. Get Rust all set up on your computer, get everything building. So yeah, I think those are all the links that I wanted to share. And then Joran, please feel free to share these slides with people. You can, follow to the developer hub that I shared. This is our organization on GitHub. I guess actually one more thing that I should show. I've been working a lot lately to maintain our awesome Substrate repository. So this is a great place to come. I mean, I haven't even personally begun to scratch the surface of all the different stuff that's on this page, and I'm writing this page. I just today I learned about this thing Halva, which is I guess like a type, it's like a truffle thing, but for substrate based chains. And I don't know if anyone else like enjoys eating Halva, but I love Halva, and I think it's hilarious that they chose that name. And so yeah, like there's just so much cool stuff there on that. And then please, I hope you can tell that I'm someone who just loves talking about Substrate. So please get in touch with me. You can email me, or then we of course maintain like a really active technical chat, and you can reach out to me this way. So that is what I got. I'll probably keep the slides up because I may want to use them for the questions, but yeah, happy to take some of those questions now.
Awesome. That was amazing. I learned so much, and like I need to go deeper into all of these tutorials. There's just like, yeah, the rabbit hole is deep, but it's cozy. I feel like there's many folks down there, such as yourself, that are just ready to help out and guide along as we go.
Yeah, we have a really great community. Like I really, we're on this kind of like weird chat platform element. And I hate asking people to sign up for a new chat platform, but we really have like such a great community. It's really fun to just hang out in that chat room. So it is a cozy rabbit hole indeed. And I did remember that I wanted to share, we have a tutorial for adding the contracts palette to a node in particular. So you wouldn't have to just kind of poke around to figure that one out. So I did want to share the link to that tutorial.
Awesome.
But yeah.
On the note of smart contracts, what's the language that we'd be learning?
Yes, we would be learning Ink. And so, yeah, actually, I shared, the link that I shared is the link for the smart contract workshop. And I'll share the other link for adding the contracts palette, my bad. But we have a smart contract programming language named Ink. So there's two different smart contract palettes that exist today. There's the EVM palette, so you can deploy EVM bytecode, Solidity, smart contracts to a substrate-based blockchain, or the contracts palette that is more our idea of a smart contract platform, uses WASM, naturally, uses WASM smart contracts. And so we have a Rust-based language that compiles to WASM called Ink. And so recently they created a really nice custom UI for working with this language. And there's a custom chain that they maintain. It's a proper testnet. So there's a faucet and everything. So you can get some faucet, some coins, and deploy some tokens and everything. And this will allow you to focus on smart contract development itself. And if you do want to learn about creating a chain that supports smart contracts, now I will share the correct link that I meant to share before. Dang it, that's not the right one. I swear I can do this right, you guys. This one shows you how to add the contracts palette to your node.
Sweet.
Yep.
That is awesome. Okay, let's take a look in here. Yeah, so along the lines of languages that we're learning, we would be learning getting involved in Substrate. Of course, we talked a lot about Rust, and now we got introduced to Ink. So do you have any advice for folks that are looking to get into Rust, get into Ink? What is kind of the path and trajectory for a noob?
There's different opinions on this. I personally believe that programming Substrate is just that. It's programming Substrate. It's a pretty heavy, opinionated framework. So This is to say, don't wait to learn Rust before learning Substrate, because a lot of the things that you learn when you learn Rust are you're kind of going to have to either forget about them or learn new concepts that replace them, particularly if you're talking about frame development, where we're using so many of these macros, which is like a language within a language. So I would say dive into Substrate head first. It's gonna feel like a lot, but this is where that great community comes in, and like it's really fun to be in that chat kind of learning together. I personally can promise you there are people there who care that you have a good time and will help you get started. And then, eventually you will start to feel like you're maybe hitting a barrier where your Rust knowledge is holding you back from developing Substrate. And that's when the Rust community really has a lot of great resources of their own to help you learn Rust. And I shared one of my favorites, which is like a game for learning about Rust called Rustlings.
Nice.
And then actually, let me actually share a couple. There's a couple more. There's the Rust book, which is, this is like, a type of Bible when you're trying to understand all of this stuff. So let me share that.
Is that Khaleesi?
That I think that was Cyan, actually, if I heard her correctly. She tends to be the louder one. And then just like in like the Node ecosystem, you use npm and package.json as like a package manager. In the Rust ecosystem, there's something called cargo that's used, and so it's pretty helpful to learn a little bit about cargo as well.
That's packed. No pun intended.
Yes. And just to kind of tie this back to Substrate a little bit more in particular, in the installation stage, which is basically kind of working through a lot on that first step of that first tutorial, I have tried to drop some helpful links so people understand, like, okay, this is actually where that component is coming into play that he was talking about. So here I will share this as one more resource.
Amazing. Okay. Let's see. There's another question here. It's a little more like general on if Parity plans on participating in Google Summer of Code or any such things. I'm not sure yet.
We definitely plan on participating in such things. I am not aware of any immediate concrete plans to participate in Google Summer of Code, but personally speaking, I'm a huge fanboy. I actually consider Parity and Google like the two companies I'm like the biggest fanboys of, and I liken them a lot in my own head. So I'd love to participate in that kind of thing, and I think it's a great suggestion. But at this time, we don't have any concrete plans to do so.
Cool. Another question that I play around with is like the relay chain being this hub and spoke kind of model, where the parachain slots are limited, right? So I'm curious if in the future there might be several relay chains that maybe a relay chain acts as a parachain, which then has more parachain slots on it, and this kind of like composable chain, relay chain kind of ever-growing hub and spoke model with its own hub and spoke. Does that make sense?
Yes. Yeah. Yes, and there is multiple relay chains. Well, I should actually qualify that. There is only one chain that's live with parachains today, and that's our Rococo test network. It is a proper test network maintained by us, all that kind of stuff. Both Kusamo and Polkadot will be relay chains in the future, and I hope and believe that there will be other substrate-based relay chains that are not maintained by Parity. That should be a thing that happens. That would be very healthy for our ecosystem, I believe. And then to get to your point about nested relay chains, so a parachain serving as a relay chain. So are you able to see my slides okay?
Yeah.
Yep. So you could imagine that this parachain here would then have other blockchains coming off of it, and they could have other blockchains coming off of it. And it would be sort of this nested model of deriving shared security that is planned. But that is a future state for sure. At this time, the main focus is on getting parachains actually implemented on Polkadot, but that's well underway. And let me actually just share a few resources for that. Cumulus, yep. If you're, I talked a lot about just kind of like general blockchain development with Substrate, but if you're really into parachain development, you'll want to check out our Cumulus workshop. And then there's just this great blog that I really enjoyed. The governance around parachains and the difference between parachains and parathreads, which I talked about a little bit. It's a very deep subject. And this was a really good blog that just kind of talked about what it's going to be like to secure a parachain slot. And it provides some pretty good, I would say somewhat high level, but pretty good information for people who are thinking about like, well, what happens if I get a parachain slot and then I lose it? What kind of requirements does that impose? So that's a really good blog.
Sweet. So many amazing resources here.
So it is like a playground for developers. There is just so much to get into.
Awesome. I want to check in on our polls. Let's see what our audience has been saying here. So a lot of folks, the majority of folks, were not familiar with Substrate before now. Some folks just had heard of it. Some people had never heard of it. So
awesome.
we can bump those people up into the next category now, and down the line you go. Next is to try some of these tutorials, and you can, next time we ask the question, you'll have said, I've done some development.
There you go.
That's super awesome. Let's talk about Sub-Zero, which just happened last week, because folks didn't hear about it. They didn't know about it. So do you want to tell people about what Sub-Zero was?
Yes. Sub-Zero was our developer conference. It just happened. But one of like the really cool things about COVID, if I'm like allowed to say that, is that politically correct, is that all of our conferences are like online these days, which means that you missed it live, but you can watch it recorded. And so it was a great event. Lots of different presentations, workshops, lots to learn. Go and check out the replay. We have another event coming up that I will shamelessly plug. It was like Beyonce mic dropped at Sub-Zero. Totally caught me off guard. I didn't know that it was coming up, but it's like another event, kind of similar in scope, but whereas Sub-Zero is heavily focused on the developer community, Polkadot Decoded is going to be more focused on like the user community and the maybe even the business development ecosystem a little bit. So many different ways to interact with these communities.
Super cool. Yeah, that's in December, I think, coming up, right?
Yep, December 3rd. Yep.
Awesome. Cool. There is another question here. It's a little bit more generalized, but I know there's something to be said specifically about the Polkadot ecosystem and these topics. So I'll throw it out there and see what happens. This person wants you to shed some light on Oracle, zero knowledge proof, and other similar concepts, which are kind of very separate concepts. But do you want to talk about any or all of those? Yeah,
definitely. So I'll go ahead and say, like, off the bat, zero knowledge proofs are something that I wish I understood. They just sound so complicated. I know that there are people doing stuff with them, on substrate based chains. I have a really hard time following ZK stuff. It's a bit out of my depth, to be quite honest with you. So I know that that's going on, but I'm not even going to attempt to really speak to any of that. I can speak to Oracle stuff because actually I have worked in, that was where I worked on an Oracle company before I came to Chainlink. So I do know a little bit about that. And it actually has a really interesting answer to the Oracle question. So to kind of back up a little bit, an Oracle is a mechanism that brings off-chain data on-chain. And so in some ways, it can just be thought of as a mechanism that makes a transaction on a blockchain. That's like what transactions do. They bring off-chain data on-chain. And so Ethereum, or I don't even really like calling out like specific other blockchains, but many other blockchains don't necessarily have native solutions for this idea of like specifically allowing a smart contract or on-chain logic to ask something to make a transaction to the blockchain. That's kind of the Oracle listens for the blockchain to ask for it to make a transaction. And so in a lot of blockchains, it wasn't considered natively, and so it has to kind of be kludged on as like middleware. But with Substrate, it was considered from the ground up. The idea of oracles and being able to invoke off-chain logic from on-chain was baked into the protocol, in particular by way of something called an off-chain worker.
Gav gave a nice intro to it during Sub-Zero, so there's a little plug there to check out one of the earlier talks, and then I think they go deeper into it. I've been trying to, as I've been organizing this hackathon and the whole slew of talks and workshops, I've been trying to fit in little modules of Sub-Zero. I'm slowly making my way through it, but I remember Gav talking about it early on.
Yep. So what it means for these off-chain workers to be baked into the protocol is that just like the runtime, they are distributed amongst the nodes in the chain. So there doesn't need to be like a hope that this third-party middleware will be out there. It's actually built into the protocol itself. The blockchain is aware of the fact that it needs these capabilities, and it has the mechanisms to implement them. So then the other thing that I want to mention is trusted execution environments, which is similar. It has some similarities to zero knowledge proofs, I think, in their privacy preserving capabilities, and also related to Oracle and the fact that they typically have some off-chain capabilities. So there is a relatively mature project that I know of called Substrate T or Substrate TEE, Trusted Execution Environment. And so this is working with like Intel SGX enclaves to offer privacy preserving off-chain computation for substrate-based chains.
Very, very cool. All this is to say, all the exciting things that can happen are happening.
Just so much to learn about. Yeah. So much to learn about. And again, in order to find that link for Substrate TEE, I went to the awesome Substrate. And so if you have like, even if you don't like know what question.
Uh-oh. I'm not sure if I'm frozen or if Dan's frozen, but I can't hear Dan anymore. So that's, let me check in here. Oh. Who's frozen? Dan is frozen. Okay, well, hopefully Dan comes back, but I think we're about to wrap things up in any case. Yeah, I mean, we'll stick around for a few moments and see if he comes back. I think he's reconnecting. Oh, do do do. He's in the Matrix. Okay, so for those of you folks that maybe came in from the outside community, this is a part of BlockHack, which is a 6-week long hackathon that we are putting on to encourage folks to build businesses in the space. Substrate and Parity and Polkadot specifically is one of our partners in that. And so we're encouraging folks to use Substrate technology to build their business on top of. And yes, I'm getting a message from Dan here. Sorry. So yeah, we're encouraging folks to build businesses on Substrate, and I think Dan is going to try and jump back in just to say farewell. But yeah, if you are not currently signed up, please visit our website at blockhack.ca. There'll be some more information there if you want to know about the prizes. We have $50,000 of seed funding up for grabs for burgeoning businesses that are being built during these 6 weeks, and as well as several other bounties that are open to different projects to complete along the way. On the way towards heading to some seed funding. So head over to our website to sign up there, and hopefully we will see you in the Discord channel where all of our chatter is happening. We have happy hours. We have a happy hour tomorrow at 3 p.m. Eastern time. If you want to tune in and get to know some folks, you can ask questions in the Discord channel. We have mentorship going on. Because we're focused on business, we have specific business-focused workshops that you can find, and we have mentorship. There's only 4 slots open per week, but a mentorship with a business specialist. So if you are part of the hackathon or you join the hackathon, you can grab one of those very limited slots per week and get some one-on-one mentorship on building a business in the blockchain space. And I'm going to check back here. Dan is trying to join back in. I'm not sure if something is preventing him, but yeah, it is worth mentioning that you can join in for free. But it is the more precious commodity of your time, and we're here to support you in doing that as you build a business in the space. Okay, fingers crossed, everyone, that Dan's going to be able to jump back in so that we can we can say goodbye to him. He's in the chats though. And let's take a look here at our polls quickly. So a bunch of folks hadn't heard of Sub-Zero, but now we talked about that. He's coming back in. Sweet.
Sorry about that, guys.
No worries. We're hanging out here and just waiting for you to join back in.
You can't take me anywhere.
No, it's all good. We had some chats about building a business in the space and using Substrate to build a business on. We also Web3 has a great grants program for Substrate-based chains that if you're building a business on Substrate, we can get you some priority seeding for those grants. So that's a huge benefit for being a part of the hackathon in the next few weeks. And so I was interested in finding out what kind of projects people were building, and it seems like we have a fairly good spread here. So we have some projects being built in the traditional DeFi space, and it's actually kind of weird now that I read back, like traditional DeFi is like such a new industry, but we're already talking about like a couple years ago being traditional. but we also have the extra nascent market of NFTs. There's some projects being built in there. There's some folks that are building a native chain. I presume they would be using Substrate for that. And then there's some projects here that say other. So I was, if you're still hanging out with us, mention in the chat what kind of things you got going on in your projects. While I pass it back over to Dan, if he had any kind of words to wrap things up. We kind of got cut off while you were talking. So if you wanted to finish up what you were saying there.
Yeah, no, I think it actually dovetails nicely. I believe when I got cut off, just kind of talking up the awesome Substrate repo again. Great place to just kind of browse around and see everything there is to see. I also shared some links to the Web3 Foundation grants, and I shared a link with a little bit more information about that bounty protocol on Kusamo that I was talking about, and the first bounty that's opened, and you can kind of go down the rabbit hole. These are actually, so I shared like Google Docs, which is like an elaborate proposal. And then there's also a website called Polkassembly where it's more like on-chain governance type stuff. And so you can see the proposals there. So one of those proposals is for the bounty, and then another is for some NFT stuff that I'm working on. I heard you mention NFTs, and so we're trying to bring some artwork to Kusama and do a gallery there. And so that's actually kind of exciting, and there's definitely opportunities to contribute.
Awesome. Thank you so much, Dan, for a super info-packed talk. I'm posting right now the link to your slides.
Thank you.
For folks to have. And yes.
Yep, and please do, join our technical chat, contact me, say hi.
Perfect. So I want to thank everybody that tuned in today, whether you're watching this on the replay or you tuned in live and stimulated us with your wonderful questions. It's been a great time hanging out with Dan. I want to also give a request for some feedback. This is the first time we're doing a fully online hackathon, doing workshops and talks using Crowdcast. So please take a second to fill out a 1-minute form and give us some feedback on how we can make these better and we can continue rolling these out. And please come over to our Discord and hang out with us there. Find out more. We'll be more than happy to help you with all of these tutorials and to help you build your businesses, help you build your projects, and get you ready to present at the end. So on that note, I will bid you guys adieu, and I hope to see you in 2 more days. On Friday, we have a great set of talks for you. So until then, I'll see you in the Discord, and I'll see you in the next workshop.
Thank you so much, Jordan. Had a lot of fun. Bye, guys.
Thanks, Dan. See you.
See you around.